So now let's kick it up a notch in terms of difficulty. We still want to rotate about the y-axis, but we're going to rotate the region bounded by these two curves. Y equals negative x squared plus 4x plus 2, and y equals x squared minus 6x plus 10. And it's pretty obvious, but I'll just kind of put it in here, that this curve is the negative x squared, right here. There we go. That one right there, that's the negative x squared because, of course, it has a leading coefficient that's negative. So if I call this y1, I'll call that one y1. And then this other one is y2, right here. I'll call that one y2. We'll give them some names in a minute. All right, so if I have those two curves and I have this region that's bounded between the two, I want to find that volume. Now the volume is going to be, and let's put in our axis of rotation, of course. Since we're going around the y-axis right here, I guess I can just put it in a solid line. I'll give it some arrow. And that means that my rectangle will, of course, be parallel to that. Oh, again, I made a wobbly rectangle, sorry. There we go. So we have a rectangle that's parallel to our axis of rotation. Okay, well, the thickness part's easy. The thickness part is dx because that's the x-axis. That's a difference in x. So I know that I need everything to be a function in x then, since I know it's going to be dx. So I need to know my height of my rectangle. We'll figure that out in a second. And I need my radius. The radius is the distance from the axis of rotation out to that rectangle. Since it's the y-axis, I actually know the radius. It's x. Again, we said a couple pages ago, if your axis of rotation is the y-axis, then your radius will be x. Easy peasy, right? Now you might think, what if it's not? Well, we'll get there. One thing at a time. Okay, so I want to find the volume here. The volume is 2 pi integral from a to b of r of x, and then the height, which in this case will be f of x minus g of x, dx. Right? We already know it's dx because we figured that out. That's actually one of the first things you figure out. You put your axis of rotation and you put your rectangle in. If it's a shell method, then it'll be parallel to your axis of rotation. So since it's y-axis, you know it'll be dx, and that means that all of this has to be x. R of x, f of x, g of x, and these are x values here. Once that's set, it sets all these other things up. All right, now the height is the part I still need to figure out. So the height is this function y1 minus the other function y2, right? It's this distance right here, which is y1, minus this distance right here, which is y2. That would be the height of that rectangle. And y1 was negative x squared plus 4x plus 2 minus the other function, which was x squared minus 6x plus 10. So that's what I'm going to use right there. That will be the height. All right, so let's do it. So we want the integral of 2 pi. Oh, there's one other piece we didn't find, which is our starting and ending points for a and b. Well, we can kind of see them right here. So x equals 1, and then x equals 4. Right? Those are our starting and end points. So we can see it's going from 1 to 4. Of course, we could find them analytically as well by setting the equations equal to each other. So if you want to find the intersections, you set negative x squared plus 4x plus 2 equal to x squared minus 6x plus 10. That would be 0 equals 2x squared minus 10x plus 8, which is 2 times x squared minus 5x plus 4, which is 2 times x minus 1, x minus 4, and lo and behold, 0 is x minus 1 or 0 is x minus 4. So x equals 1 or 4. There you go. If you want to do it analytically. It wasn't necessary because we can actually tell what it is from the graph. I, of course, have it already graphed in Desmos as well, because this is a Desmos graph in case you missed it. And there we have it. So here it is. So you have your intersection right there at 1, right? X equals 1, and then x equals 4. So just like we thought. But if you wanted to know how to do it analytically, there you go. All right, so that means that I'm going to take my integral from 1 to 4. And again, not required to do it analytically, just fun. All right, r of x, we said was x. So r of x is x. And then we're going to take f of x, which was negative x squared plus 4x plus 2. And we're going to subtract g of x, which was x squared minus 6x plus 10. Yes, I know I could have simplified them up above, but of course I'm trying to write the notes out in terms of using the formula. All right, there we go. So we just need to combine like terms and simplify and things will be grand. So this is 2 pi integral from 1 to 4. And that's x times, and then let's figure out what's inside there. We have negative x squared minus an x squared, which is negative 2x squared. 4x minus a minus 6x, so that's plus, 4 plus 6 is 10. I don't know what I'm doing right there. Plus 10x. 2 minus 10 is negative 8 dx. All right, which is 2 pi times the integral from 1 to 4. And then it's negative 2x cubed. Oh, you know what? 2 goes into 2, 10, and 8. Let's be smart about this. Let's make it a 4 out in front. There we go. That's wiser. I mean, why deal with more numbers in here than we have to, right? So negative x cubed. Oh, forget it. Negative x cubed. So I'm distributing. X times x squared is x cubed. I factored a 2 out. So I'm doing 2 steps at once. Aren't I ski? And then x times 10x is 10x squared, but factor out a 2, so it's 5. So 5x squared. And then x times 8 is minus 8x, but I'm going to factor a 2 out, so it's going to be minus 4x. So I'm distributing the x, and then I'm also dividing by 2, right, and pulling or factoring a 2 out. That would be 4 pi times negative 1/4 x to the 4th plus 5/3 x to the 3rd minus 4 halves x to the 4 over 2 x squared, which of course is 2x squared. And we're going to take this from 1 to 4. This is what Desmos is for, right? So we are not going to do this by hand. No, 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 no. That's just silly. And I don't think I actually even showed it. I just found the integral and proved it was 45, but I can show it to you. So if we make it so that, call this thing h of x equals that thing we were looking at, negative 1/4 x to the 4th plus 5/3 x to the 3rd minus 2x squared. Oop, x squared. There we go. And then I just find, I don't need to graph it. I just want to have it. So then I find h of 4 minus h of 1. And I can make it into a fraction if I so desire, which is 45 over 4. So there we go. So this is 4 pi times 45 over 4 with Desmos. I'll show you. And that means that it's 45 pi. 45 pi inches cubed, which was about 141.372 inches cubed, depending on if you were asked for an exact or an approximate answer.